So we're going to look at an example of using the future value formula for an annuity. So here's our example. So you deposit $400 at the end of each month. So a deposit situation, already in your head, you should be thinking that's an annuity, right? It's not just a one-time drop that we're doing in, like a principal. It's actually several times that we're going to be doing it along the way. So we're doing the end of each month. It pays 3.6 per year, and it's compounded monthly. How much will you have saved at the end of 6 months? So the idea of this $400 deposit happening frequently throughout, we can do the calculation of future value that we've seen in the past. So remember, future value in sort of a compound interest format was taking present value and adjusting it with our I and our N. And we could do that for each of our $400. So we invested the first month $400, second month $400, third month $400, etc., etc. So we could actually calculate based on that each time we did an investment, our new sort of rate of interest and our new future values that we have in our deposit or in our accounts at the end of each month. So we can do that and then add them all up at the end to get a final value, but that takes a long time, right? We have to do that formula 6 times. So for an annuity, when you actually have this regular payment, let's use the formula instead, which will give us our final accumulated value with just one calculation. So we have our future value formula. So let's put down the values that we know. So we know we're depositing $400 at the end of each month. So that's my deposit. So DEP, $400 at the end of each month. And then we have 3.6 per year. So that's our rate of interest is 3.6%. And again, we know we have to write that in decimal format. We have the idea that it's compounded monthly. So our M value or our compounding periods, every month we're going to do it. So our compound value is 12. And we're looking at the end of 6 months. So our time frame is 6 months, but remember our time always needs to be relative to years. So you can think about 6 divided by 12 or 1/2 as your time frame. So we have our basic values that we have, and we do need to compute our I and our N. So remember, I is equal to R over M. So 0.036 over 12. And our N value, which is M times T, which would be 12 times 1/2, which gives me an N value of 6. So we need our 400, we need our I value, and we need our N value to substitute into this formula. So 400 multiplied by our square bracket, so 1 plus I, which is 0.036 over 12 to the exponent 6 minus 1 in brackets, all divided by I, which is 0.036 over 12. So please, again, make sure that you're thinking about following BEDMAS. We do need to do this bracket first, exponent, subtract, then our multiply, then our divide. So 400, I'll do a few steps in here. So we have our inside bracket will be 1.003 to the exponent 6, and then we're going to minus 1 divided by 0.003. So again, we want to make sure that we do our exponent, subtract 1, multiply by 400, divide by our denominator, and you should end up getting approximately 2,418.07. So you'll notice that this value that we're getting with our formula is what we would have got if we did the 6 intermediate steps and then did our addition at the end of it. So a lot easier to use the annuity formula than to think about, well, what happens when you do those deposits every month, or depending on if it's a month, different deposit times associated with it.